We see so many electrical devices in our lives these days. Motors, generators, transformers, and all of them are based on two fundamental properties of induction. A current through a wire produces magnetic field, and a changing magnetic field produces voltage across the wire or the conductor. Using this amazing experiment, you can see both these properties and see very counterintuitive things, as converting a non-ferrite or an aluminium disc into a magnet. For this you need the induction apparatus, which is 2 kgs of insulated copper wire, some secondary wires, nails, ferrite magnets. This is how you make your primary coil with 2 kgs of insulated copper wire of about 3000 turns. In the middle of the coil, you insert some metal, iron rods, some nails to make a strong core. A strong core concentrates the magnetic field inside the primary coil and hence makes the effect hundreds of times stronger. Scrape the ends of the wire and connect it to the power source. You should remember to tape so that you don't get a shock when you are doing this experiment. This should be connected to a AC power source. Now, when you hold this coil on the needles, they don't attract. But the moment you switch on the current, this coil produces a magnetic field and the iron magnets are attracted towards this electromagnet. This magnet does not attract the aluminum discs. But see what happens when you insert this magnetic disc on top of this primary coil. The moment you switch on, the disc becomes an electromagnet. This is because the eddy current are produced inside this aluminum disc and they make it a magnet. If you put another disc on top of it, that also becomes an electromagnet and starts to attract the previous disc. This is independent of which side you put the disc on. If you put 4 of them together and switch on, they become a strong electromagnet with such a force that they fly out of the coil. Take a secondary coil with about 1000 turns and connect it to a bulb. Now see what happens the moment you take this secondary coil and bring it closer to the primary coil. Amazing! This demonstrates the concept of transformers. See, the moment you put this coil near to the primary core, there is current induced because changing magnetic field induces voltage, and there is a changing magnetic field because an AC current is passing through the primary coil. This is a coil of about 200 turns. Notice the brightness of the bulb. This is much brighter than when we had 100 turns. As the voltage induced in the secondary coil is proportional to the number of turns. We have made this another coil and connected it to the bulbs at various different turns. After 20 turns we have connected a bulb, after 40, after 60 and 80. Now when we insert this close to the primary coil, see how you can clearly see the number of turns affecting the brightness or voltage generated or voltage induced in the secondary coil. Beautiful demonstration of electromagnetic induction. We have wrapped these nails together and we will see the effect of a strong core. If we bring a coil with 100 turns, see how dimly the bulb is lighting. The moment we put this core inside the secondary coil, the effect is hundreds of times bigger because the magnetic field is concentrated now. Now we have a small coil with about 1000 turns and we have connected an LED to it. The moment we bring this coil close to the primary coil, again the LED starts to glow because there is voltage induced in this coil. Now here we have a ferrite magnet connected to a spoke. See, the magnet attracts the nail. Now the moment we bring this magnet close to the primary coil and switch on the current, the magnet starts to rotate. This is the basic concept of an AC motor, where the electromagnetic field produced by the primary coil interacts with the magnet and makes it rotate. See how children are having fun with induction.